Hello, my name is Debbie Smith and I'm your adult education tutor at Coventry City Council for this course on maths for children in early years foundation stage, nursery and reception, year 1 and things are a little bit different at the moment in terms of delivery due to current situation with COVID, so please bear with me. I will go through things as well as I can and hopefully we'll get to this fairly easily. As you can see from the screen, my name's Debbie Smith, as I've said, and there's my email address should you have any questions you want to send my way. There's also a couple of links on the screen to the adult education pages where you can find out more about other courses on offer. Okay then, so here is the telephone number for the adult education service should you have any need for it or any queries. To make you aware that we follow the safeguarding strategies in Coventry. We also follow and promote the Prevent agenda to protect vulnerable children and adults in the area. We follow and model the British values that are taught to your children in schools, and this is throughout our service. Okay, course overview then, just to give you an idea of what we'll be covering over the next 5 weeks. Practical maths and written maths, we did both. We'll be covering addition, subtraction, multiplication. Think about some methods that are used in school today, how they might be different or the same as what you were taught at school. Lots of resources and activities to help you practice at home with your children, and vocabulary so that you can learn some of the terms that your children will be learning as they're learning them, and some expectations for the curriculum, what your children might be learning when, so that it will help you to help them best according to their age and stage. So session objectives for today, we're going to be looking at an introduction to early years foundation stage and key stage 1 maths, basic number skills, we'll be thinking about place value, keywords and vocabulary, and some games for you to play. Lots of resources. We do try to give you things to practice with. Here are the task images for you to consider. Sometimes I'll want you to have a think what you are, and there's the man with the thought bubble there. And sometimes I ask you just to make notes, just to jot a few things down. They're for your own benefit, they're for your own use, but it just might help you with the task and get you thinking. Okay. So the National Curriculum of 2014 is the most up-to-date one for maths, and the guidance, real key things to pick out is the aim for children to become fluent in mathematics. So it's being confident, it's being able to recall and use knowledge that they've learnt, knowing which piece of knowledge they need or which skill they need for the thing that they're doing at the time. So it's about making children more confident, helping them to reason mathematically. So what is going to be the best way of working this out? Would I be better to use subtraction or addition? Could I use my number line to help me with this? So not just what's my times tables, but what would be the best way of solving the problems, and again using their reasoning and their fluency to help them solve problems. It's making maths more everyday, so it's less about today we're learning algebra, today it's your 10 times tables. It's more about, so if you had 3 of these and 6 of those, how many more would you need if 12 people were coming for dinner? It's about getting children to relate maths to everyday life, to encourage them and to make them more enthusiastic about learning. So number sense. Number sense is understanding, to recognise numbers, what their position is and what their value is. Okay. Number sense is getting what a number means. Okay, it's about meaning. It's less about that's a 7, that's a 5, that's a 4, and more about what's its meaning in relation to other numbers. What's the point of it? Okay, not just chanting by rote. So as I say, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. That's the way I was taught at school. We've moved on with maths now. It's not just what facts do you remember, it's what do you need them for. Okay, so it's what's the best way of trying to tackle this problem. Okay. A real simple concept that for very young children is quite important. Thinking about your early year stage, nursery and reception age children, is about the value of numbers. Okay, it's about understanding the permanence of a number. So, for instance, here we've got 5. 5 is always 5. Okay, whether we're looking at spots on a dice, apples in a basket, plates in your kitchen, a number 5, 5 on the bus. 5 is always 5. It would always mean 5 things. Okay, the fiveness of 5 we call it. So making a solid foundation. If there's 5 there today, and you look in the cupboard again tomorrow, it will still be number 5. You know? And it's the understanding of numbers and their values. Getting those foundations really solid is really important, and that's what we do in the very early years at home as well. Feeding into this then, think about counting. Take a moment to have a think. What order were you taught to count in? How did you count first? Start off 1 to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you do countdowns? Thinking about rockets zooming off to the moon? Counting up, counting down? 0? Yeah, the idea once you've counted actual things that sometimes there's nothing. There's naught, there's 0. Yeah. Counting up and down, again with our countdowns. In schools, then we start counting in 2s, 5s, 10s, 7s, and onwards. At this point, it wouldn't be classed as times tables, although it is the foundation for it. It's about recognising patterns. If we're counting in 2s, it's every other number. If we're counting in 5s, it's every 5th number. It's about getting children to see how it works and gain understanding first, which will then help them when they move on to multiplication. Odd and even numbers. Moving on to fractions then, halves, quarters, thirds, eighths. Thinking about quite often the classic cake, pizza, cut into equal pieces, which then leads into decimals, 0.25, 5/10, 3/100, all those sorts of things, and positive and negative numbers. So we know 0, we know 1 to 10, but actually going the other way, introducing to children that actually you can go into negatives as well, and how the operations are affected. Lots of different ways. Counting is really important, and those early foundations will really support. So take a moment to have a think. How do you count with your child or children at home? I bet you do it more than you realise that you do. Do you count in nursery rhymes? 1, 2, 3, 4, 5. Once they caught a fish alive. Do you know any nursery rhymes in other languages? When you're playing, do you do a hopscotch where you count the numbers as you throw your dice? Do you count how many skips you can do? Do you count ready, 1, 2, 3, go when you're having a race? Lots of different ways with counting. Ever seen the number blocks on TV? Once you've heard that theme tune, you won't forget it. You know, a nice program on CBB is definitely worth a watch that just goes through some number learning with your children. Track games, the ones with the start and finish, like Snakes and Ladders, for instance, or Ludo, working your way around the board. And then don't forget those everyday tasks, counting the stairs on the way up and down, looking at money in your purse or when you're paying for something. How many carrots have you got on your plate? How many knives and forks do we need for the table tonight? How many cups are we going to use? You're doing it all the time, probably without realising it, because maths is integral to daily life. We just don't necessarily notice it, particularly when we get to the more difficult concepts. Straight away, then a nice activity for you to do with your children at home, the star counting game. You can see from the picture in the top right hand corner, there's a lot of resources that will be emailed to you along with this presentation, and this is one of them that you can print off. You need a counter and dice for this game as well, and I've sent you a printout as well where you can make your own dice and your own counters for these sorts of games, so you'll have your own set. Simply in this game, the instructions are on what you'll receive. You roll the dice. What number did I get? Oh, I got a 4. Right, then I need to find a square with 4 stars in. Oh, there's one. I'm going to put a counter on top, and then you keep going until you've covered them all up. And who gets the most? Who's covered up the most is the winner. Okay. You could play it for 5 minutes. You could play it with 3 children. You can make it work for you. Just getting children to have fun with numbers and recognise numbers. Okay, then one of the really first important things that you can practice with your children when they're learning maths is number bonds. Okay, and they're really important. Okay, you know what I mean when I say number bond? I bet you do, you just might not know them as number bonds. We're talking about two numbers that together make another number. So for instance, if we're doing number bonds to 10, you might have 0 and 10. You might have 5 and 5. Can you think of any others? Take a minute to jot them down. Let's have a look at them together. Okay, so a really good way of doing this sort of activity is almost methodically. So if you know 0 add 10, if you take 1 from the 10, you've got 1 add 9. If you take another one from the 10, 2 add 8, and so on. And the way this has been organised on the PowerPoint, you can see 1 add 9 is alongside 9 add 1. It's the inverse, it's the opposite. And it's a really good way of teaching children from early on that actually, oh, with addition, if I do it the opposite way around, I still get the same answer. Okay. Really, really good to learn, really useful for children. So this is a really nice way of doing your number bonds with small children. And you can make this really easily at home. Draw around your hands or your child's hands. Just stick the bottom part down, leave the fingers flappy. How can we make 10? And you literally fold the fingers down. So hold on, I've got 10 fingers here. How many more am I going to need? Oh, 9. So you'd write 10, add 0 equals 10. And again, you can go through it methodically, or you can get them to just randomly work them out. You can write them down at the bottom. You could get a new piece of paper over the top and do that another time. The idea being that the children aren't just being told, they're learning. It's very concrete. They're very able to see how we make 10 because they're making 10. And it's a really lovely little activity to do at home as well. So another way to represent this in maths, which your children will see in school, it helps children to see relationships between numbers. It's partitioning, it's known as. So for instance, in this one, looking at this, we've got 10, which is made up of 8 and 2. Okay. And the other way around, the idea being you can see relationships between numbers because 2 and 8 together make 10. Okay. So the idea is it feeds in. Let's have a look at the next one. Have a think. What's the missing number here then? Again, we're thinking about our number bonds to 10. We know 10 is made up of 9 and 1. Did you get it? And again, in the same way, 9 and 1 make 10. Okay, so you're doing the opposites to each other. Next one. Think about the activity we're doing. What's going to go into that box? 10, yeah. 5 and 5 gives us 10. Good stuff. This one. Same again, 4 and 6 gives us 10. It's not about trying to trick anybody. It's just about trying to show how easily these techniques work together. And we get children using these sorts of partitioning tools very early on because they'll be able to use them for more complicated maths as they move up, and they already know how to use it. So it's really quite handy. And thinking about transferring these skills, if they know their number bonds to 10, they can quite easily transfer that to 100. So for instance, if you know 4 and 6 make 10, you can quite easily work out that 40 and 60 makes 100. Okay, it's transferable. If they can do it to 100, we can start working to 1,000. They can do it between 0 and 1, so you can talk about a half, a quarter, and they can do it even smaller down between 0.0 and 1/10. They can work in hundredths as well. Okay. This comes further on, but it's just showing that it's transferable. What they learn with their number bonds, they will be able to carry on throughout their maths in school. A really nice resource now, again, been emailed out to you, a number fan. It's like this. Quite often in schools, I'll have them for the children to use when they're doing group work and the teacher wants to see what individual children know. So it might be as simple as show me, teacher might say, show me 5 plus 4. So the children look through their numbers, 5 plus 4, 5 plus 4, 5 in my head. 9, my answer's 9. I'll find their 9, I'll hide the other numbers out the way and hold their 9 up. Okay. The idea being if the teacher asks the children to put their hands up, obviously you only get an answer for one child, or somebody calls out, everybody's copying each other. Actually, the children are working on their own, and the teacher will have 30 numbers pointing at them. They can work out who needs a bit more help. This sort of thing, and it's fun. The children like having something tactile to hold. So it's a fun way of doing it. You can also do it for multiple digits. So, for instance, 7 out of 10. Oh, 7 out of 10. 7 out of 10. Oh, I know that one. 17. So again, rummage through your numbers. Took everything else out of the way, and there's your answer. Okay. A bit more there for you to look at. Idea being that the children will be asked to work out things in different ways, and they can do it. And there's also a decimal point in here too, so you can do things like the bottom one, the sum of 0.2 and 0.8. You've got your decimal point in there too. Okay, so quite a nice tool, and your children will use them at school, so you can make your own. It'd be quite useful. Number lines. I'm sure most of you probably seen number lines. Again, quite often they'll start at 0 or 1 and go up to 10 or 20, particularly with smaller children. You can get them for any numbers, obviously. You can get blank ones as well. So that, for instance, if you are working in thousands, you'd need a very long number line to get to 1,000. But if you start it at 1,010 and finish at 1,050, that's for the problem you're doing. That works. Also, you've got your ruler. If ever you haven't got a number line, it can be quite useful if you've got a ruler with you. It works in a similar sort of way. And thinking about testing and things, when children are tested as they move through school, if they're taught early on how a number line works, they can draw their own. If they're trying to work out a problem at home or in that sort of situation, they can just literally draw a line, draw their own, have a go. And again, you can have a go at that yourselves. 100 squares. Again, very popular in the classroom, particularly with smaller children. The idea being you can see numbers and where they fit with others, and it's not just a row of numbers, it's 100 numbers there, so you can see what's greater, what's less than. You can find patterns going down, going up. You can find out what's 10 more, 10 less, 1 more, 1 less, very easily. And for instance, teachers might cover a number up and say, what's the hidden number? And again, you've got a lot of things around you, okay, so it comes between 5 and 7. What comes between 5 and 7? Let's have a think about. Can't remember. Let's look down. What comes underneath that missing number? 16, 26, 36. Can you hear a pattern there? I think it might be 6. You're going to have a lot of fun with these things. This has also been emailed to you. Play with at home. So we can do things as simple as counting forwards and backwards in ones with our 100 square, counting in twos. And quite often children will be encouraged to use counters to mark those twos, then maybe colour them in so they can see the patterns, because you very clearly get quite an interesting pattern. Children are learning just by looking at that visually that every other number when we're counting in twos. And it's the digits 2, 4, 6, 8 and 0, and you can look at that following down the page. So they're not just being told when we're counting twos, we say 2, 4, 6, 8. They can see what we do, and by seeing it and the reasoning behind it, it makes it far more likely that your children are going to be able to engage with it and use it and apply it somewhere else, thinking back to that curriculum detail. Counting in tens then. Same again, children are taught you go down to count forwards in tens and up to count backwards in tens. Once they've secured counting in tens, they won't need the number square to do that with, but just to start with, it's about the concrete of them being able to see it and help them to predict and recall their facts. Again, cover them over, ask children what's missing, and you can do that at home quite easily. Counting in fives, very similar again, children will see a pattern. They'll start to learn that the last digit when you're counting in fives is either a 5 or a 0, which will help them. They may not remember what 10 times 5 is, but they might just remember that the answer will have a 0 or a 5 on the end, and that can help them to begin to work it out. Really quite useful. There's a lot you can do with them, and children do enjoy playing with them and using them and just having all those facts to hand quite often. There's a nice game here now I'm going to show you on the ICT Games website, which is really lovely. And this is a 100 square game, and you can choose find any number. So you could do 10 more, for instance. I'm going to click on 10 more. You can also choose to play together. Do a 2-player game. So player 1, it's your turn. Press next. So here we go. It tells them what they need to find. 10 more than 44. Right, find 44. Where is it? I've got it. 10 more. What do we do when we're finding 10 more? Do we go up or down? We go down. Let's click on it. Yeah, well done. 54 and the star comes around it. Player 2, it's your turn. It tells you how long it's taken as well. So you could have a bit of a competition if you wanted to, or you can ignore that completely. And player 2 has a turn, so they'll click next. 10 more than 11. Do you know this one without looking? Let's have a look. What's your answer? Oh, it's not 22. Let's try again. Yeah, there you go. It's 21. Really simple game that your children will enjoy to play. Right, that's the end of the first part of the presentation. I really would recommend now that you pause here, take a short break, get up, move around. It's quite intense sitting and watching these things. You don't think it's for very long, but it takes quite a bit of concentration. So please feel free to pause me there, come back when you've had a chance to have a bit of a comfort break, and we'll carry on. Thank you. Okay, we're going to move on to something now, talking about the concrete, the pictorial, and the abstract. You either will or won't have heard of this, but you'll see a bit more as we move on. So, when children are being taught in maths, we go through these stages. We go through the concrete, the pictorial, and the abstract, okay? So when we're doing a concrete, children actually have images of objects, or even real objects sometimes. So in this case, cookies. So it's a real good way of hooking children and getting them to relate real life to what they're doing, okay? And getting them to know what the numbers look like. So Jim has 12 cookies on the left. Julie has 8 cookies. How much do they have altogether? Okay, so at this point, the children are thinking cookies. They're not thinking add, subtract, they're just thinking cookies. And they're all there for them. So all they've literally got to do is count them up. Again, they're practicing math skills without being scared by words like addition and subtraction and altogether. Oh, they're literally, you've got 12. Oh, I can see I've got 12. Let's count them. I can see I've got 8. How many are there altogether? The sorts of things that they will have seen at home, like we were saying before, counting knives and forks for dinner and all that sort of stuff. It's just about making this into problems, everyday problems, okay? Once children are secure in concrete, they move on to pictorial. Okay, so same problem again. Jim has 12 cookies, Julie has 8 cookies. How many do they have altogether? Okay, so this time, rather than actual images or real cookies, we've got objects. We've got the cubes there, haven't we? So we've got purple line. If you count them one by one, you've got your 12, a gap, and then you've got your orange line of cubes separate. Your 8. We push them together so the children can see that's 12 and 8, and then we push the purple and the orange together so that they can see we're adding them together. It's all together. Okay, same problem. The children are just ready to move on. So rather than having to see that there's 12 cookies and 8 cookies now, you know, they don't have to see a cookie to know that there's 12 there. Okay, they can use counters, they can use other objects. Okay, and this is a picture. It's an image now. It doesn't have to be physical things. The children have learned from the concrete and can move forward. Okay, once they're secure in that, they can go to abstract. They don't need pictures. They don't need concrete objects now. It can be as simple as the sums. So this time round, Jim has 12 cookies, Julie's got 8. How many do they have all together? So they don't need to draw them. They don't need cubes. They can literally write and carry out the sum 12 plus 8 or 8 plus 12. Okay, so they've moved on. They've grasped what 12 of something looks like. They've grasped what 8 of something looks like. They know the number sense of 12 is 12 all the time, 8 is 8 all the time, and they can relate it to other numbers. They've got number experience at this point, okay? But they know why. The concrete and the pictorial gave them the chance to know why they were doing what they were doing and how it related, which is really important. Okay, children are taught as they move through school to decide on the best way to solve problems. Okay, if they've got the knowledge and experience, they might be able to solve problems in their head mentally, if they're simple enough. Okay, otherwise they might need to write it down and work it out, do jottings. Okay? So as children move through school, they'll be asked to consider, can they do it in their head using mental strategy? Do they need to jot it down or should they write it down? Children are taught to work out which is best. Okay. An important thought. Problem solving is at the heart of mathematics and should be the focus of what is taught in school. Basic skills in mathematics should be defined to encompass more than just computational facility. Maths must go beyond just teaching a method. We touched on this earlier. It's about getting children to know how to relate the maths that they learn to everyday life, solving problems. Have I got enough money to buy the bread and the milk? what time does the bus come? Is it before or after I get up in the morning? It's not just about barking facts. It's about being able to solve every day real problems. You know, what time do I need to get up if I've got to get up 20 minutes before the bus comes? Solving everyday problems that are relatable to life. It's not just being able to do something because you've been told you need to know your times tables. It's about how that helps you to reason and solve problems. Mastery is a big part of the strategy now. Being able to master something is when not only have you learnt the skill, but you can carry it out reliably and almost automatically. You know how to do it. You don't even really think about doing it. Do you drive? When you were first learning to drive, it took an awful lot of thought, clutch up, clutch down, accelerate, gear change. You probably don't think that much about driving anymore. I'm sure you concentrate, but in terms of these skills, once you've mastered it, they come to you naturally. You do what needs to be done without thinking, clutch up, clutch down, start, stop. It just happens naturally. And this is what we're aiming for in maths for children. They can master these things. They're good at doing it, and real mastery means they could show someone else how to do it because they completely understand. They haven't just learnt something by rote. They know why they do it, how they do it, and how it relates to the things. Okay, this is what we're aiming for in maths now. Let's have a look at this example. Here's Sally. Sally knows all her times tables up to 12 by 12, but when she's asked what 12 times 13 is, she looks blank. Does she have fluency and understanding? She doesn't, does she? She's learnt her times table, she's learnt the facts, but she doesn't know how to use those to help her. She hasn't got the fluency to take one thing and use another. She's been so busy learning 8 times 8 is 64 that she hasn't got the reasoning and the fluency that's required to use what she's got. It's really important to gain that fluency and understanding, not just recall. And again, this is what your schools will be working towards. Let's get children enjoying maths and knowing why they're doing it, not just learning lots of facts. Okay, partitioning them. We're going to work on this next week as well, but just as an introduction, have a look at that table, okay? Going from left to right, millions, 100,000s, 10,000s, thousands, hundreds, tens and ones. Partitioning table. Children learn to partition into columns according to how many digits they have. And now rather than units, when I was at school, it was hundreds, tens and units, and now 100, tens and ones. And that's simply because it's easier for children to understand why that we use ones, that we use units. Okay, so digits or numbers. Let's have a look at the number is the whole thing. So here we've got 134, okay? The digits are separate in each column. So 134 would be written as, have a look at the headings, 1H, 100, 3 tens, T, and 4 ones. So 134 is the number. The digits are 100, 3 tens, 4 ones. Okay. When we're doing partitioning, which we looked at with the number of ones earlier, we're thinking about the value of each digit. What is each digit worth? So this time, thinking about getting our tens and our ones, we look at the number 72. And 72 is made up of 7 tens, 70, and 2 ones. You see that? We're looking at tens and ones, 7 tens and 2 ones. Let's have a go at another one. Okay, have a look at this one. 87. I want you to jot down how many tens and how many ones. 87. For 87, we'd have 80 at the top and 7 at the bottom. Yeah. Super stuff. That's what mine would look like. Okay. Next one. Putting in that missing box. So we've got, they've done it the other way around. They've told us this time, haven't they? So this time we've got 30 in the top box, 2 in the bottom box. What do you think the whole number was? Can you write it down? 32? The same. This time, 62 in the first box. And we know we've got 2 ones. How many tens are we going to have in that top box? You get to 60. Super stuff. Next one. Right. Once children are able to separate them out like that, this is another way children will be taught to separate their numbers. So we've got 5 10s and 6 1s, and that makes 50 and 6. So that's taking what we've just done and turning it on its side. Okay. This is a way children will be taught to write addition and subtraction. Okay. So 56 equals 50 plus 6. Yeah. 5 10s and 6. Okay. Next one then, 85. If you're splitting that off into 10s and 1s, what would you have? Let's do it together. 85, we'd have 80 and 5. Yeah. Next one, 13. Split it off into 10s and 1s. What would we have in the first column? 10 and 3 1s. Next one, we'll get this one, 90. How many 10s? 9 10s. How many 1s? 0 this time. Remember, 0 does have a value, okay? Going into numbers with 3 digits this time, 358. So how many hundreds first? 300. Yep, don't forget those zeros, they're important. How many 10s? 5 10s, we've got 50 and 8 1s. Yep, 358. Next one, 571. How many hundreds? Jot it down. 500s. How many 10s? 7 10s and 1 1. Ooh, going even bigger now. Going to our thousands. Have a go at jotting this one down. 2,734. How many thousands? 2,000s. How many hundreds? 700s. 3 10s, 30 and 4. Okay. And the idea is that we're getting children to realise that it's not 2,734. It's 2,734. Okay. Another one here. 6,800. 0 10s because there is nothing in that column. 2 1s. Okay. Just for your own benefit, when children move into decimals, we can do the same here. So 3.4 is 3 1s and 4 tenths. So we're going the other way. Okay, so we've got hundreds, tens and ones. After that, we can go into tenths, hundredths and thousands. Further up from where your children will be now, but just to give you an idea that they can continue to do this with trickier numbers, and it follows the same concept. So 8.71, 8 1s, 7 tenths, 100. Okay, it's transferable. 4.98, 4 1s, 9 tenths, and 8 hundredths. Okay, so once they've practiced that in school, and they'll do that for a little while, children then can determine the value of the underlying digit. What is the value of that underlying digit? Quite simple. 7 1s, yeah, 7. Okay, look at this one then. Think about what we've just done. What is the value of the underlying digit? It's not 4, it's 40. Yeah, can you see? It's your 4 10s. And from the activity we've just done, you begin to see that. And once children can see why by doing that partitioning, they'll know why. When they look at the numbers, they'll learn to know why. Okay, it's not just because it is, it explains them why. Okay, this time 574. What's the value of that 7? 386. What's the value of that 3? Is it 3? It's 300. Yeah. Going into our decimals again, 3.2. The value of that 3 is 3 1s. 8.09. The value of that 0 is 0 tenths. Okay. 5.25. The value of that is 5 hundredths. As I say, you'll learn more about tenths and hundredths as you go a bit further up through the curriculum, but it's just there to show you that it's transferable to more tricky things. Okay. So, place value card. So, from the activity we've just been doing, you've been able to see how important it is to understand that there's hundreds, tens, and ones. It's not just 462, it's 400, 6 10s and 2 1s. And this is what place value cards are really good for. They come in various ways, and we will do a bit more work on them next week, but just so that you can see they're there. And there is an email, there is one I've emailed out to you that you'll be able to print off yourselves and use. And the idea is, if you look at the top box, you can overlay them so children can see how they're hundreds fit with their green hundreds fit with their yellow 10s and their red 1s. Okay, it's really good, really useful, and it will support what they're doing at school as well. Okay, take a breath. We're going to stop there. Just run through what we've looked at this week. We've done quite a bit actually. You've listened really well. I'm hoping it will help you. Vocabulary used in school, we've looked at place value, partitioning, position and value of numbers, number bonds, the importance of mastery, and you've got some resources and websites and games there. You'll also find quite a few activities for you to try at home. The star counting game has been emailed out to you. The number bonds hands activity I've explained. There's a picture of it again, so you can have a go at that at home. You've got a number fan, number line, place value cards all coming out to you at home as well. And there's the game that I showed you on the ICT games. All of these, any links and things like that. And there are some more nice websites that you can go and look at some games. There's a list of them each week will be emailed out to you so that you can have a look at your leisure and explore some of them at home with your children as well. So next week, we're going to do more of a focus on addition. We'll be using place value cards again and thinking about all those sorts of techniques and partitioning, so you'll see how it fits in to understand how addition's taught in school, and some activities and online links to go with that. Addition actually goes over a couple of weeks because it really is quite a stronghold of what the children will learn, but we've got some really lovely activities to go with that too. Right then, that's the end for this week. Thank you very much for attending. There's my contact details again should you have any questions. I hope you've enjoyed the course and you found out a little bit more and that it'll be really useful for helping your children with mathematics at home. Thank you very much.